Alright, so we have to find the magnetic field at point P. I guess the first thing to do is going to be draw a line connecting I1 with P. Right, and we'll call that distance R1. R1 can be found from the Pythagorean theorem to be 0.283 meters. We're also going to need this angle theta here, and theta can be found from inverse tangent of opposite over adjacent, and that is 32 degrees. Okay, so let's figure out directions first. The direction of the magnetic field at point P due to I1 is going to be along a line that is perpendicular to R1. Okay, it's making a right angle with that distance. It's a tangential force. Now the right-hand rule tells me that the current due to I1 wraps around I1 like this. Right, it wraps around in a clockwise direction. That means that the magnetic field due to I1 is going to point down like this. That's B1. Now, let's see, if I draw a horizontal line for reference, I know this angle is 32 degrees, and since this angle plus this angle have to add up to 90, that tells me that this angle is 58 degrees. Okay, so B1 points 58 degrees below minus x. Now, as far as I2 is concerned, a line that connects I2 to point P goes like this, and of course it's perpendicular to this horizontal line that I've drawn. And the right-hand rule tells us that the magnetic field for I2 wraps around I2 in a counterclockwise direction, so that means B2 is going to point off like that in the positive x direction. Alright, so I've got the directions of the two vectors. I just need to calculate their magnitudes, right? So B1 is mu naught times I1, which is 9, over 2 pi times 0.283. That is 6.36 microtesla in a direction 58 degrees below minus x. And then B2 would be mu naught times 3 over 2 pi times 0.15, so that's 4 microtesla in plus x direction. Okay, now I just need to break these into components and add up the components. So B1x is minus 6.36 cosine 58, which is negative 3.37. B1y is minus 6.36 sine 58. Right, I guess I should have written at some point, I'm using standard Cartesian sign conventions, right, where up is positive and to the right is positive. Since B1 points down and to the left, the x component is going to be negative and the y component is going to be negative. That's minus 5.39. Okay, and then the x component of magnetic field number 2 is just 4. And the y component of magnetic field 2 is 0. You don't have to do any trig for that. It points right along the x-axis. Alright, so the total x magnetic field is minus 0.63 microtesla, and the total y magnetic field is minus 5.39. So, I'm going to combine these two now, make a little coordinate system. We're going to go 0.63 in the minus x direction, and we're going to go 5.39 in the minus y direction, and that's going to be our total resultant magnetic field. It's going to make some angle alpha with the minus x-axis. So the total magnetic field, the magnitude of it, can be found with the Pythagorean theorem. And that is 5.4 microtesla. And then the direction alpha can be found with inverse tangent of opposite over adjacent, which is 83 degrees, and it is directed below minus x.